All right. And yeah, today I'm very glad to welcome Jessie. We recorded already a podcast session a while ago, some years ago. At that time, it was for in the Honeycomb session. And yeah, with a lot of luck, we just reconnected at KubeCon in Atlanta a couple of weeks ago. And now it's my pleasure to welcome you in my podcast session. So happy to have you here.
Thank you.
Maybe you can just introduce yourself for the audience.
Great. My name is Jessica Kerr. I go by Jessitron online, jessitron.com, etc. And what I care about is systems, learning systems. And I think the software systems include the team in that. Mm-hmm. So I care about software learning from our teams, which is like we code it. And I care about our teams learning from our software. And that's why I now work in observability at Honeycomb.
Nice. It's very nice that you mentioned like your definition of a system, because like in previous episodes, I already talked with other people like Russ Miles, but also like Casey Rosenthal. If normally people from our space are talking about a system, their definition is just technical. But a system by design is a socio-technical system. So you need, of course, technical components, the software. And there are so many other important elements, like you mentioned, so the people that are building and running those systems. And is there any change you can identify in today's system and the complexity of those systems?
Oh, yeah, of course. Because now we have the running software, we have the team that modifies it, and we have the AI agents in between. So there's a complete third component in the socio-technical system. It's now a socio-agented technical. Yeah.
Yeah. We need to find a new term for it.
Right. Yeah, there's these three completely different, using the term loosely, intellects. I mean, there's the deterministic software. There's the people, the human team that decides what it should do. And then there's the coding agents that we use. So the people are communicating to the coding agents, which are changing the code, among other things. Mm-hmm. And then sometimes you have agents involved in the running software, and that's a completely different part. So now our software is not fully deterministic anymore.
Yeah.
Yeah, it's a very different system, and it's more powerful than what we had before. But we're even less familiar with how to do it.
Exactly. And that's like, there is a lot of opportunities coming up with those new designed systems, and they are very dynamic. But how to say it right? Are we ready for this change as organizations?
No, of course not.
Why?
But here it is.
We cannot change it. It's already there. But what are like this? Why we are not ready? What do you think?
Why we're not? Well, I don't think we ever got to figure out how software systems work in the first place. Right?
Yes.
Right? Like how to design into software, that's still new, because software as a medium, like compared to paint or bricks or metal, software as a medium is completely different. And you can kind of design right into it. And when you do that, like you encode your design into what should it do. And then the software, like in theory, does that or something close. And then you have to find out how it interacts with the real world, because a piece of the system that we haven't added in yet is the people using the software or the other software using the software. That's a different boundary that is not what we're mostly talking about as developers. But yet that's the system that we care about, is how our software impacts the rest of the world. That's our real objective. Okay.
Yeah.
So we were still working on figuring out how to really craft software and grow it and improve that interaction with the rest of the world and care about it and keep learning ourselves, et cetera. We didn't get to figuring that out. I don't think we mastered it. And now you add agents into the mix and we don't know what we're doing, which is fun. My friend Eric Evans says that the introduction of LLMs is the most exciting thing since the internet.
I agree.
that
Yes.
he was around for like when the internet was new, and that was very
Mm.
exciting, and people were exploring what can we do with this, and this time reminds him of that.
And now with like the first steps done in that new direction with agentic driven systems, is there a gap coming up, a gap between like the expected behavior from engineers that are designing those new systems and then really like what those new systems are doing? Is there a gap?
Oh, definitely. Yeah,
A
because we're
good
used to,
one or a bad one?
oh, I I mean, the part where we don't know what we're doing is disconcerting,
Hmm.
but there's very high potential, right? We don't know what we can do yet.
Yeah.
So in that sense, it's good. But we are used to writing deterministic software. I mean, I got into coding because I was studying physics in college, okay, just
Hmm.
bachelor level. But once we got to quantum physics, I was like, well, this is ruined. Now I can't like make nice predictions about how the system is going to go. What fun is this? It's all just probabilities.
Yeah. Yeah.
And coding was more fun because the computer did what you told it. And that's gone now. It's gone.
Yeah, it's partially gone. That's right. And hmm. So I don't want to sound like this paranoid guy, but I need to ask this question again, or like more in this direction. Most people, if they are talking about AI, they are just assuming, hey, there will be a prompt. I will enter a prompt and something will come back, and then this new AI system is doing something. But how do nowadays engineers really interact with it? Is it Have you seen it in production, or is it still in this prompting approach?
Well, there's two aspects. There's using
Yes.
AI for coding, and there's using AI as part of the software.
Mm-hmm.
So when we're talking about AI as part of the software, there's that black box of we send it something, it sends us something back.
Yeah.
But it's never just the prompt. It's
Mm-hmm.
also what tools you give it and what context you give it
Yeah.
when it's an agent, not just what context you actively give it, but what context you give it access to
Mm-hmm.
through tools. So we get to control what it knows and what it can know. And all of that influences its output. And then we also can change how we react to its output. Like what do we do when we get a parsing error? And what different checks and uh, corrections do we apply to
Mm-hmm.
it? That's a thing. But there's still a black box in there. And that black box, we can't just test. For an API, you can write contact tests and you can
Yes.
say, I believe when I send it this, I get this back. And then you can run that against the API and you can run it again when you think maybe someone else on the other side has introduced a bug. And you don't get contract tests with LLMs, you get evals.
Mm-hmm.
And that's a whole nother space that we have to learn how to do.
Yeah, and those responses, the context where this response is coming out of is every time a different one. It will change. And in unit testing, integration testing, yes, you've got a lot of control compared to the new way of dynamic systems where agents are part of it. But how to really make sure that those systems are working as expected? And how much should we control them? And what is
Yeah.
now the
Yeah, we
new
can't
way of
define correct
observability?
anymore. We can only define good enough.
It's good enough for now. Yes.
Right? Right? Can we define good enough and can we define better? And usually, I mean, that's really hard. But if you can get there, you can improve.
And I mean, in the old days with observability, you have installed maybe some agents, they have scanned your system, they have collect data, maybe you have been using some open telemetry informations. With now those agents in place, what needs to change from the way
Okay.
of how we observe our systems?
We have to care more. We have to be more deliberate about it. So you mentioned installing agents for observability. That's like level one. That's like
Mm-hmm.
the bare minimum. But if you care about your software and you really want to know what's going on, and not just in your software, but in the software plus users system,
Mm-hmm.
then you want, nowadays people use open telemetry for this, but you want your software to emit telemetry about the business domain. You want it
Yes.
to tell you through its telemetry what it's doing, who it's doing it for, like user IDs, what it's using to make decisions. Whenever I see an if statement, whatever that clause is, I like to stick it on as a span attribute. So it shows up in my distributed trace so I can know which path the code went down, that kind of thing. You want your software to tell you what it's doing and to spy on your users for you. Which features are they using? How are they using them? Is it what you expected? And now we need it to spy on the agents as well. What did we send them?
Yeah.
What did they send back? What tools did they invoke? What came back? And then what came out at the end? And how did our application react to what came out in the end? All of that is part of your application tracing. And the less we can predict what the black box is doing, the more we need all of that information. Both how did we get to this context? What happened in the interaction? And how did our application react to it? What resulted? And if we can get some sort of feedback or indications from the user of whether that was good enough, really valuable. So we need way more observability.
And as of now, observability is more showing what happened in the system. How close do we need to get to that real-time approach? How fast should we be able to see what happened in the system?
Oh, like what time do you need between this happened and I can see it?
Yeah. For example, if there are only humans in the loop and no agents are doing stuff automatically in the system, so they are not part of the system, do I need less time?
That's a good question. I mean, we all like real-time observability. At Honeycomb, we have an internal SLO that your data should be available in about 5 seconds from when you send it to us. We can't control the delays before that.
Yes.
And it's usually less than that. So you want to be able to know quickly. Now, the reason, pre-AI, the reason Honeycomb has always been designed this way so that you can know quickly is so that you can deploy something and see whether it worked very quickly. And now that cycle of do something and look can be even faster if an agent is involved. And with agents, they can take in a lot of information and react faster than we can in a lot of cases. But for that, they need to be able to gather the information quickly.
Yeah.
So like the availability of the information can be a limit on how quickly your agents can work, on the speed of that feedback loop. And also how quickly does a query return? This is one reason that like the things Honeycomb has always focused on are even more important with AIs, because we put a lot of emphasis on making every query fast.
Yeah.
And suddenly, I mean, we did that so that people could run multiple queries in a minute. And now it's like the agent running tens of queries in a minute.
Yeah. So, and now what is like the solution? We need to be even faster as before?
It's still about enough, it's about fast enough. Because honestly, do I want my agents making changes to my system at the rate of 10 seconds each? Not sure about that, actually.
It really depends on like the use case or context we are talking about. Maybe if you are in a trading system, maybe. But if you are like in a healthcare system, take your time.
Right. Because you do want humans in the loop. If anything really interesting is going on. If it's not interesting, agents are just somewhere on the scale of, we know this happens, we automate it. Like in Kubernetes, we know the service gets busy sometimes, we scale it up. We know it goes down sometimes, we restart it. There's a level of predictability you can fully automate. And then we don't know what's going on and we better look at it, and we better look at the wider implications. That's people are involved.
Yeah.
And agents can do something in between, right? They can do, well, we don't have an automated response for this, but we can make a really good guess.
Yeah. As long as we are controlling the context or the data which has been used to produce a new response. If this is not controlled by a human in the loop, I mean, it could be getting very ugly with like those responses by an AI agent. If I remember correctly, there was like a company trying to replace all the support people on call. And after a couple of days, the agent was responding in a way that this was not good for the company. Because he was getting out of control. He was collecting more and more data from all the conversations. And then he, don't get me wrong, but suddenly changed his mind about the company he should work for.
That's hilarious.
It is. That's why you need like boundaries for your system, for your agents, and don't get everything out of control. It could hurt you as well.
Yeah, too much information is too much information.
Yeah.
More is not always better, because a lot of like when I'm working with an agent for coding, a lot of what I do is clear information out of its context.
Yeah.
It's time to start over and give it just the stuff that was right, so it doesn't get hung up on the stuff that it was wrong about earlier.
That's one of those very important concepts of AI. AI will not generate something new. It will always build on top something which was done in the past. So it will not create a new idea or a new whatever way of solving an issue.
We like to think that, but I think combining multiple things from the past is how we come up with something new.
Yeah.
And I think it does that.
Yes. But it's yeah. Okay.
Yeah, I mean I don't know whether it's intelligence or not. I don't think that word has a definition that's useful.
Yeah.
But I do observe that it can surprise us.
That's true. And if you see it as something which can support you, can help you, can maybe give you a little bit of guidance, but the final decision or like the last step, it needs to be approved or done by a human, then it's a strong way of building new systems or solving very complex issues.
So do you think agents have a place in automatically responding to some system conditions, software system condition?
Yes, if they are running in kind of some boundaries and if the context is defined very precisely, then yes, and then they can act way faster as anyone else. But it would be a horrible solution to, let's imagine there is an old system running since 10 years, and now you're putting in a new freaking awesome agent, and he's now part of the system. The system is not designed to handle this. And I mean, it's the same issue like in the old days, there was like, let's say some monolithic applications. And then there were showing up new companies like Netflix, microservice driven, everything fine. And now Netflix was very successful with the microservice approach. And then the old companies that are still running on a monolithic approach, they are now trying to be the same like the new stack of Netflix. That's not working. If you can build a system from the ground up, prepared for agents, this will work.
Like cloud native. But now we
Correct.
have some sort of agent native that we don't know what it is yet.
Yeah.
But something like so part of building your software to be ready for agents to help is going to be good observability, because observability feeds its context, right? It feeds what it can know. And if you've got boundaries around, okay, the error rate has increased, and what people do in this situation is go look at the traces until they find a service that's failing more than normal. And the first thing they're going to do is restart that service. And the second thing they're going to do is look for a recent change in that service and roll it back.
Yeah.
And if that's always what people do, and I think that's pretty common, an agent could identify the service that's failing, identify changes. It could do that rollback while contacting people. And so then the people start out a little bit more ahead of knowing whether the rollback helped.
Yes, more like this, let's say, agent on call. So the agent is observing the system. He's able to see all the data from the observability tools. Maybe there are some error rates popping up, and he was trained to now take the decision, okay, I could try to solve it with just a restart. that's based on all incident data. That's based on all the experience from my team. And they teach me as an AI agent to do it, exactly that. But again, as I'm on call, I will inform my team that I did exactly that one time, not like multiple times over and over again.
Yes. Don't do this on a 10-second loop and try different things every 10 seconds. That's going to be chaos. The bad kind.
Absolutely. and now you mentioned chaos. And now let's zoom in exactly that topic. Why? Because you mentioned some seconds ago, you need to know what normal looks like. So if there is like a service getting out of control, you need to exactly know let's say on a Tuesday at 10 a.m., this is normal for this service because the traffic is going up for whatever reason. But this knowledge needs to be also not only part of your teams, of your experts that are building those software, it also needs to be part of the agent. And how should you train it? How should you teach and educate an agent how he should react? You need to put him in not normal conditions. And the best way to do it, from my perspective, is to introduce some chaos, to really change the system in a very controlled way, to really, inject some errors in the system so that the human can detect if the agent is now doing the right steps.
Right. So the question of whether agents are going to be useful, whether you want to put them on call in production, is going to be answered potentially by chaos engineering experiments. Of while we're sitting here watching it, does it screw it up?
Correct. And you need to do it in a proactive approach. It's not like a good idea to install the agent, go into production,
and then wait for an incident.
Exactly.
And then the incident comes and you're like, oh crap, that agent just did something. Oh right, we turned that on. What were we thinking?
Yeah. How to shut it up? How to shut it down?
How do we shut it down?
Yeah. And now the agent is restarting all his friends because they're all on call now. That's where it's getting complicated. And that's, I mean, you need to be prepared for those moments even more now with this new way of building systems.
Yeah, because you need to test, does it react appropriately?
Yeah.
And then does it stop when it should?
Absolutely. And something we have created at Steadybit is, of course, you can run those experiments in a running system. But now there's a ton of data coming out of those executions and tests and all that stuff. It's at some level very hard to figure out what is like the root cause and how could I solve it. And that's for me a strong use case to then use this data in combination with observability data to really identify with AI help what was going on here. What is like the root cause? How should I address this issue?
Yeah, what really happened? What did the agent see? What did the agent do? Correct. And we have to introduce instruments in a scientific sense, like little spyware to see what's going on, like thermometers or telescopes or whatever. These are all instruments. And with agents, our instruments are like recording the ins and outs, and the agent reporting its thought process. And then in the software system, observability gives you all those instruments so you can see what happened on that side, and the agent is telling you stuff. And then Slack is really useful now that we're mostly remote. And if it's the middle of the night in an incident, I certainly hope we're dialing in, then we have some record of what the people were thinking and saying.
That's where I can see, like, let's imagine you're an SRE on call, and wouldn't it be nice if, let's say, your AI SRE buddy has already done like a first review or an audit about the situation. He has collected all the information and you will get a nice summary.
And he's made you a custom dashboard just for this.
Yes.
Now you still need to go in and check that those graphs are querying what you think they are querying.
Absolutely. And
but it's
more like helping you to be more focused, to focus on the right elements, but then still it's your final decision if you would like to restart after 100 times the service again.
Oh, right. Because maybe the problem is actually in the configuration data and there's some discount that's defined in an invalid way. And you could put that on the list of things for the AI to check next time, but next time it's going to be something new.
Yes, absolutely. That's true. That's absolutely true.
Yeah. So there's even more. You mentioned like incident review, I think, but we get all this data, and the question is, how do we learn from it? Because when you have a chaos engineering experiment, voluntary or involuntary, incidents count too. I guess it's planned or unplanned. When we're looking at learning from this, we want our agents to learn from this.
Yes,
so
correct.
we specifically want to be able to improve their prompts or run books or whatever you want to call them for what to check, what to look for, who to inform. And I think this might be a promising advance in incident review, because companies that are like, oh yeah, we could learn something, blah, blah, that, and don't want to invest in that. If you tell them, oh, but we need to improve our agent prompts so our agents can be more effective, that they believe in.
Yes. Yes. And also a fun fact, we are working with like some students from an university, and they have implemented their own SRE agent. And they are using our tool to really, there are two main use cases. First of all, they want to identify and learn if the agent is really doing the right stuff, because they are like the SRE experts and they have trained the agent, and he's now part of the system and he's doing changes in the system. But the second, and for them more important fact is, or use case is, people that are getting this agent for the first time in the hands, they don't trust the system. They don't trust this SRE agent. So they want to see a validation up front. And that's where chaos engineering is again coming in. So they are installing the agent, let's say in a Kubernetes cluster. He has been trained to react under specific conditions, and he's able to do that. And then out of nothing, they are running chaos experiments with Steadybit to really show the potential customer, hey, our agent is doing the stuff.
So you can build that trust.
Yes, correct.
That's so important.
It is for both ends.
Yeah. Yeah. So, yeah, the agent has to be able to work with its context. And so the people can improve that. But the people have to believe the agent is useful. They have to look at its output. And then an exercise for us, like one of the ways that we have to change to work with these agents, is when its output is wrong, to not say, stupid agent, and throw it away, but to say, all right, time to give it better context.
Yes, it's always like, it's getting back to this, start with the why first. Why this result was so bad? There needs to be a reason. Is the data not correct? Is the agent not...
It's the same problem as with root cause. Is there really a why? No. I don't even think why is a healthy word.
Yeah.
It's so vague and it's so blamey. But if we ask, how could this be different? Then we can change the input. We could potentially change the tools or the model, whatever. There are lots of ways that it could be different. And you don't have to assign any of them to the root cause in order to change some of them and get a different result.
Or with other words, what do I need to change to fulfill my expectation? Because, I mean, same.
Or even what can I change? It's not your fault, right?
No.
You're not the only one who could change as well. I mean, there's other parts of the system that could change, but like, what is within my scope that I can do to such that my expectations are met? And sometimes that means changing your expectations of, well, the agent's not going to solve it, but it's going to give me some information that's better than nothing.
That's true.
Or it doesn't have to be right to be useful. It can still give me ideas or clues.
Yeah. But then again, I'm like, or like the human is the last responsible in the loop. He needs to take the final decision.
Yeah.
All right. Anything from your side you would like to talk about?
I'm happy this conversation has gotten me excited about what we can do with these agents and how they can fit in as helpers. Because they're never going to replace your SREs, but they can make your SREs even more effective. And I love that part about building trust. And chaos engineering becomes the evals
Exactly.
for
As
the
a
automatic
validation point.
SRE agents. Yeah, totally. And
Exactly.
that's, I mean, I think chaos engineering is wonderful. And I think incident reviews and learning from incidents are wonderful. And they're wonderful for humans. And if people will invest in them because they're also good for agents, then both the agents and the people will get the benefit.
That's true. Absolutely. But therefore,
Same with observability.
yeah. But I mean, therefore, there needs to be a shift in this mindset. There needs to be a change in the practices, how people are doing it. I mean, so many times in so many conversations, I'm still identifying this strategy hope. We are just hope everything will be all right. But hope is not a strategy, and your
Hope is a
system,
cop-out.
yeah, your system, especially like your socio-technical system, will not react as you expected in that moment.
Yeah, the agent's not going to get better with thoughts and prayers, but it will get better with better context.
Yes, over time. But therefore, it needs to be, even like an agent needs to be living in a system that is tolerating faults, is able to handle failures, and is not like something bad. If we can, and that's like this mindset shift I'm talking about, is if a fault or a failure is a learning opportunity, and we will react as, hey, we can identify something new, which we were not expecting at that point in time. That's a big change in the mindset.
Yeah, yeah. And then we can fix it at lots of layers.
Yeah.
Like you could be like, okay, there's a bug in the code. You could be like, okay, somebody put in some bad admin data. Let's make that not possible.
Correct.
Or you could be like, hey, agent, next time this happens, yeah, just restart it and we'll deal with it the next day. Or roll back the configuration and we'll deal with it the next day. Or whatever it is. Yeah, it gives us another layer at which to fix/mitigate
Yeah,
problems. That gets back to how we don't yet know how to work in these systems. And the fun part is some of the stuff that we learned about software but haven't fully adopted, like chaos engineering, like test-driven development. If you're writing a durable code with agents, test-driven development helps. And you can get them to write the test, so it's a lot less work. And you can get them to make the test output really pretty. And you can refactor the tests, and you can write generators to create the data, which I love to do, but was super time consuming. But now I can shave all those yaks because all of that code is disposable code, and I don't have to look too hard at it. I can just let the agent do it, and if it works, it works. So we have these new tools to use practices that were always useful but were not widespread, but are now even more important.
Yeah.
Yeah, there's a lot of growing to do.
Absolutely. I was just smiling a bit because test-driven development, and if I now assume like the agent is creating the code and he's also writing the test case, wasn't there one rule that you shouldn't do that? Like even like with the old way?
I used to write the tests and write the code. The trick is like that you look at them.
Yeah.
But I also require seeing a test fail before I will believe it when it passes.
That's true. Yeah.
And there's things like approval tests. Approval tests are just here's what the HTML was before, here's what it is now. Is it the same? I really like those because it shows me exactly what changed in the HTML.
Yeah.
And it's not that the agent wrote a sneaky test. It's a straight comparison.
Okay, good.
So there are considerations, but absolutely, I have the agent write the test and the code. I just look at it.
That's good. And yeah, then thank you very much for joining me. What is the best way to reach out to you? So if someone wants to, get to know you, would like to get in contact with you.
Jessitron.com. And I have a newsletter if you want to hear from me less than once a month.
Nice.
And also, if you want to chat, especially if it's about observability and or open telemetry or whatever you're trying to get working, honeycomb.io/office-hours has like a Calendly. And I get to have half-hour meetings with random people and find out what they're thinking about, and it's super fun.
It is. Absolutely. Okay, then. Thank you very much for joining me in this session. It was my pleasure to talk with you, and hope to see you soon on the next conference, maybe.
Thank you.
All right. Thank you very much.
This was great.